Welcome to Rges Pre-Algebra, Lesson 25A. We're working on a review of sections 6.1 through 6.7. Now we will be having a quiz on this on Wednesday, and recall that there are several different kinds of graphs. See if you could pause and name them all real quickly, and then I'll put them down for you as a review. So were you able to name the 6 kinds? Now the first 3 kinds are similar to one another in the sense that you are just graphing the data. Of course, you need a label for the graph. You'll need that for all 6 types. You'll need to decide your horizontal and your vertical axis and what they represent. Recall that a bar graph, now typically a pictograph will be horizontal and it'll be with symbols. And you'll have to decide how many, for instance, if you're talking about the sales of cars, maybe one car would represent 1,000 vehicles or whatever, and that would have to be on the key on the bottom. For bar graphs, you'll have 2 different kinds. You can decide to have a vertical or a horizontal bar graph, and you'll have to decide what, again, which you want to represent, what part of the data represents what line. For instance, maybe the number of students would represent the vertical, and the grade on the test would represent the horizontal, something like that. Okay, and of course you want to label each axis. Okay, so go back and look at some graphs if you don't remember the labeling very clearly, because you'll want to know that for your quiz. Line graphs can have 3 fundamental shapes. Once the points are graphed and you've connected them, it could be a curved, it could be up and down kind of thing, and that would be a broken, or it could be a line. And this would be the basic overall trajectory, or straight. Okay, so curved, broken, straight. And that would be the trajectory or the shape of the graph. And all the things that we said about the other 2 apply. Now 4 and 5 are distinct because we're talking about parts of the whole. So you're going to get the percentage first, and then you're going to do the parts of the whole, either the parts of a whole circle, which means that we would have to multiply by 360 degrees our portion. So a part or percent times 360, or the length, we'd multiply by the length of the rectangle to get the part. And then the histogram is the only one that represents a range. And by that I mean a frequency. How many, for instance, how many students scored within a certain range, let's say between 60 and 70, or how many students scored on the test between, they should be the same size, sorry, between 70 and 80, that kind of thing. So look again at 211 to remind you of that. Definition of range on any of these is the difference in the data points, or the numbers, values, from the largest or the highest value. For instance, let's say we're graphing mountain ranges. We could go from the highest and we would subtract the lowest or the smallest. Okay. Highest to the lowest, largest to the smallest, but you get the idea. There we go. So that's range. So don't forget that definition. Okay, the last thing to review then would be the statistical calculations. You have 3 in this chapter, and you have only really learned the first one. The second one will be, and the third one will be on the focus of today's assignment. But for the review and for the quiz, you only want to know the first one, which is the mean. What is another name for mean? Do you recall? from last tape? It is the average. And how do you get an average of data? You would sum them. Another way to write a sum, that we call this a summation symbol. So you would sum all the data and you would divide by the number of data points. In other words, let's say I had, I sold, so let's say I sold 12 books, let's say, and I had a price for each one of them. Those prices ranged from $3 to $4 to $4.25, etc., all the way down. Let's say my most expensive one was $14. And I had 12 different books I sold, so they each had a value. To get the average or the mean value of the books I sold, or the mean selling price, I would do what? I would add up all those values, and I would divide by 12. And that's your review. Well, now I want to go on to the new idea, which we gave you a little bit of preview to last time, and I'll expand on that now. That would be section 6.8 and 6.9. Now recall that the two other statistical calculations that you learned about, the first one is the mean, the second one that we're learning about is the median, and that is the middle value. Recall, we want to think about it two ways. One, if we have an even, let's do the other one first, an odd number of values. So we have 1, 2, we would first off, we need to order them. So you'd put them in increasing order, order the data. So let's say I had 7. 1, 2, 3, 4, 5, 6, 7. Identify the middle value after you've ordered it, and that would be the median. If I had an even number, what would I do? Let's say I had 8. I would still order the data. That represents 8 values I put in order. I'm just not writing in the orders or the values there. Okay. And notice that I don't have a single median point. My median or my middle is really right there. So I would take these two values, I would add them and divide by 2. And that would identify the median when there's a even number of values. So you are being asked to do that section if you haven't already finished it from your class time. And I'm trying to see if there would be anything at all complicated for you. I don't think there is. We will go over the answers in class, but I don't think that will be troublesome to any of you. Just remember that before you can find the median, this is perhaps the most important thing to remember, is that you must order the data. Now, the next thing we'll look at, and this is going to be our third statistical calculation, is called the mode. And the mode has to do with frequency. Like if I have that data point more than one time. That's all we're looking at. Okay, so if I had 5 numbers, let's say I rolled the dice. Let's say I rolled the dice 5 times, and I got a 1, 3, 4, 4, 5. And that's it. Is there any one that I have rolled more than once? That's the mode. The mode is 4. If I rolled the 5 dice again, and I got 1, 4, 4, 4. Let's say I roll it 6 times. Okay. So this is the one that has the highest frequency. So now my mode is 4. Let me do one more time. What if I rolled the dice and I got a 1, 3, 3, 5, 5. Well, notice this frequency and this frequency are the same, and so we would say, if you ask me what the mode was, there's not a single mode. Okay. If, by the way, well, I'll go to that next, but it is bimodal. There's two that have the same higher frequency than the others, and they are 3 and 5. My last example here would be, what if I rolled 1, 2, 3, 5, or 4, and 6? Let's say, what is my mode? There is no mode. So if there is none that stand out higher than the others, that's how you would answer it. And let me see if there's any more questions to think about that. Let me review that one more time. There's 3 statistical calculations, all begin with an M. You'll want to know, name them, and you'll want to define them. The mean is defined as the average. The median is the middle term, and the mode is speaking about the frequency. Okay, which piece of data is the highest? In other words, let me see, the number that occurs most frequently. Okay, that would be a good definition. So know these 3. And I'm going to glance 1 minute to see if there would be anything confusing here that I haven't already gone over for the mode. Okay, it might go without saying, but I did not mention it, is just as you want to reorder before you find the median, it's not necessary to reorder before I find the mean. I'm just going to add all the numbers up and divide. But for the mode, or for the median, I want to reorder, find the middle term, or the 2 middle terms, and take the average. And for the mode, I must rearrange also at the beginning, or reorder. Go ahead and reorder from the smallest to the largest, and you're, of course, doing that so that it's easy to identify the frequency. We'll take a brief preview of the next section before we're finished. It is frequently convenient to make a scale drawing. We could make a scale drawing of something that in reality is much larger, like a scale drawing of a house. I don't need a piece of paper as big as my house. I would just assign a value or a scale. What does that mean? For instance, I might say, okay, 1 inch on my drawing might be equal to 5 feet on the building. Something like that. Depends how big the building is. Maybe I'd say 1 inch equals 1 foot, or whatever. You get to choose. This is called the scale. When the left side number represents the drawing, and the right side number represents the actual item, or reality, maybe I should say. Okay, so maybe I could say 1/4 inch equals 50 miles on a map, or something like that. It would just depend on how big or small an area I'm trying to represent on my map. And so that would be another example of a scale. Again, this is the drawing, and this is the reality. Okay. Now notice in both these cases, the drawing has a lot smaller value than the reality. So these are reductions. Okay. These are reductions. The drawing is smaller. I could also take something very small, very minuscule. Maybe I'm trying to draw a small, intricate, maybe the pieces of a watch and how they fit together. Everything, well, before digital watches, the old-fashioned spring watch is what I'm thinking about in my mind. Okay, so we've got a little bit of machinery here, and we might have to enlarge it so that I can see the pieces easily, when maybe in reality they might be maybe not microscopic, but I would want a hand magnifier to be able to see them clearly and to see their shapes. So maybe I would say that 3 inches equals 1/2 inch. Still, the order applies. This is the drawing, this is the reality, and so in this case you could see that the left-hand side is larger, so this is an enlargement. Here in the example of the map, the left-hand side is smaller, so this is a reduction. So that's one of the first ideas you want to understand. Now, the second idea will have to do with the fact that we are going to use our ratios. That's really the most convenient way to do this. So when we're thinking about a proportion, let's say we have A over B equals C over D. Recall two ratios set equal to each other as a proportion. Maybe I know 3 of the values and I'm trying to solve for the x. How do I do that? I cross multiply. I always do whichever cross gives me the x on the left-hand side. So this would be A times x equals B times C. And then you're going to divide and solve for x. Now that's the overall math. But let's look at how that would work. The scale for a scale drawing is 1/2 inch equals 5 feet. So this is a reduction because the left-hand side is smaller. How long is the line segment if its length on the scale drawing is 3 inches? So on the scale drawing, it's 3 inches. So how much is it in reality? In other words, what does that 3 inches represent? Well, you might, in this one, see very clearly that if 1/2 inch represents 5, then a whole inch would represent 10, and 3 inches would represent 30 feet. But what if it's not so clear? I'm going to make it a proportion. My scale and my reality, okay, or my drawing, let's keep our same words. The scale drawing is really what it is. So if they use the word scale, so let's just go ahead and put scale drawing and then the reality, okay? So my scale drawing is going to be 1/2. My reality is going to be 3 inches. And when the reality is, what did I say? 5 feet. Oh, I don't know. Oh, I'm sorry. I'm reading down here. Okay, I want to read up here. Okay, 1/2 inch represents 5 feet. So don't lose your measurements there. I ask how long is the line segment, that would be this part, if the scale drawing is 3 inches. So cross multiplying, and you're going to get 1/2 x equals 3 times 5, or 15. Multiply by 2, and x equals 30. Now, my recommendation would be, if you have mixed numbers, to go ahead and convert them to improper. So on the next example, they say the scale for a scale drawing is 3 inches equals 1 inch. Recall, the left-hand side is always the scale. Okay. So what is the height of the actual object? If the height on the scale drawing is 4.5. So we're going to think of our numerator as the scale. My denominator is the actual. My new numerator will be the new scale. On the scale drawing, it's 4 1/2. And what would the actual be? Just like that. Okay, scale drawing versus the actual. Now, the first thing I would do is convert that to improper. 3 over 1 equals 9/2 over x. Cross multiply, you get 3x equals 9/2. Divide by 3, which means put the 3 in the denominator. And I could multiply it through, or I don't have to, because in this case, I would just go ahead and cancel that, and I get 3/2. Now, for these, most of the time they'll want you to then answer it by putting it back into a mixed 1.5 inches. So if I have 4.5 inches on the scale drawing, that represents 1.5 inches on the actual object. Okay, I think that you'll be able to follow that. Now the next one, 3.11, talks about distances on a map. And distances on a map is the same idea with a different application, because a map is just simply a scale drawing. So if you look at page 222, it says 1 inch equals 10 miles. And then it says, what would the question be? It says the distance on the map from Johnsonville to Dalton is 1.5 inches. To find the actual distance, set up the proportion, and how many miles is that? Right? So I would say 1, my scale drawing, is to 10, my actual miles, as 1.5 is to x. Sometimes you can just see this automatically. This is a half more, so a half more than 10 would be 15 miles. So if you can see it just like that, that's fine. But if you can't, go ahead and cross multiply. 1 times x would just be x. I won't write that one in there. 10 times 1.5 would be 1.5 times 10, so you'd pull that over, and x equals 15. So I think that you'll be okay to do that, and if you have any questions as you start working on that in class, feel free to talk to me about it on Wednesday.